Okay, in this video we're going to talk about radicals. Now in mathematics, radicals are basically just numerical expressions with square root in it. Okay, so there's different types of expressions like this. So we have what's called the entire radical, where you just have square root of some number. Okay, let that number be a, or 7 or root 94. Those are entire radicals. Okay, so everything is under the square root. And then we have something called a mixed radical, where it's more in the form like this, b root a. So you have a number outside and a number inside. And so 2 root 7, 2 times root 7, is that what that would be, is a mixed radical. And say negative 3 times root 5 would be a mixed radical. And you'd never have, in our cases anyways, the square root of a negative number when we're working with real numbers, because it's not a real number. So if you have the square root of a negative number, then that's what's called an imaginary number, and we're not dealing with it in this course. Okay, so then we have what's called, what I'm calling is a binomial radical, when you might have the sum of two square root terms. So for example, root a plus c, or root 7 plus 4. So that's an entire radical plus a constant. Or you could have root a plus root b, or root 6 plus root 5. Okay, and you can't put these together unless you evaluate them, because they're not alike. Or you could have some mixed radicals in here. So say you have a root b plus c root d. Could look like 3 root 5 plus or minus. So I put a minus there. 7 root 11. Okay, so that's mixed radicals in a binomial form. Okay, so what can we do with these radicals? Well, there's three things that we're going to look at. Well, we can simplify radicals, and we can multiply, divide radicals, and we can add and subtract radicals. Okay, so the first thing we're going to do is to simplify radicals. Okay, so simplify radicals looks something like this. So say you had an entire radical of root 45. Well, mathematicians like this to be simplified into something where you have the smallest number possible under the square root. Well, this means you're going to have to break this up. And it just turns out that 45 equals 9 times 5. And we know that 9 is a perfect square. And the nice thing about square root is we can distribute it in, and that becomes root 9 times root 5. And root 9 is just 3. So 3 root 5. This is root 45 reduced. Okay, so this is the reduced radical here. And that only works if you can break up the number under the square root into the product of a perfect square times another number. Okay, so 49 probably couldn't be reduced, because 7 times 7, well, 7's not a perfect square. Okay, what about this ugly one here, a squared b? Well, that can be reduced. Root a squared root b, which equals a root b. So So that's generally the form you want to put the number in, something that is a perfect square times b, and then you can reduce it to this. Let's get a more difficult one here. How about root 704? Well, if you just keep checking this and dividing numbers in and seeing what it is a product of, well, it happens to be the product of 64 times 11. And root 64 we know is 8, so that reduces to 8 root 11. Okay, so that's simplifying radicals, is breaking it down so that you have the smallest possible number under the square root. Now, let's try multiplying radicals. Okay, so, well, this is quite simple actually. So if you had 2 root 3 and then you multiplied that by 5, well, you've got 5 times 2 root 3. Well, that's just going to be 10 root 3. You think of the root 3 like a variable, like x. So 5 times 2x is 10x. So 5 times 2 root 3 is just 10 root 3. What about 2 root 3 times 3 root 11? Well, then that would be, well, you're going to multiply the constants outside, so 2 times 3 is 6, and root 3 times root 11. Root 3, root 11. Well, we know that we can break up a square root like this into 2 pieces, so we must be able to go backwards. So that becomes 6 times root 3 times 11, which is 6 root 33. Okay. So basically you multiply the constants, you get the 6, you multiply what's under the square root, you get the 33. So you could jump right from here to the end. Now, what about multiplying a binomial times a binomial for these radicals? So how about 2 root 7 plus 3 times 3 root 5 plus 4. Okay, so the way we do this is the same way we would do it with algebra. Okay, so we use the FOIL, okay, the distributive law for a binomial times a binomial. So we multiply the first, which are either these two. Okay, first, then the outside, then the inside, then the last. Okay, so 2 root 7 times 3 root 5 is going to be, well, 2 times 3 is 6, and 7 times 5 is 35, so 6 root 35. Okay, and then we're going to do the outside, which is 2 root 7 times 4. Well, 2 times 4 is 8 root 7. Okay, so 4 times 2 root 7. And then the inside, 3 times 3 root 5. Well, 3 times 3 is 9. And then we just have root 5. And then the last, 3 times 4 is 12. Okay. And that's how you'd multiply the binomials. Now, what would happen if you had some of these square roots the same? Well, if you had a root 7 here and a root 7 here, well, you'd be able to collect those just like if there was an x and an x. But right now you don't have like terms, so you cannot do that. Okay, so I'm now going to jump to adding and subtracting. So add, subtract radicals. Well, if you had 2 root 7 plus 5 root 7. Well, that means you're adding root 7 to itself twice, and then another 5 times. So that means you have 7 root 7s. Okay, so it's like collecting like terms. What about root 45 minus 2 root 5? Well, at first look, it looks like you can't do anything here because they're not like terms. But as we worked on earlier, we worked on root 45, it reduces to 3 root 5. So we can replace the root 45 with 3 root 5. Then minus 2 root 5, and that just equals root 5. Okay, so now if you put these two together and you did something like 2 root 3 plus 1 times 3 root 3 minus 5, if you multiply these all out, well, you're going to get 2 times 2, which is 6, and 6 times root 3 times root 3, well, that's root 9. Okay, and that's going to be nice because root 9 is just 3, so it turns into a constant. And then we have, that's the first, then the outside, negative 5 times 2 root 3 is going to be minus 10 root 3. Then the inside, 1 times 3 root 3 is going to be plus 3 root 3. And then minus 5 when you multiply the last. Now we have like terms here. We can put those together. And we also have 6 times 3, because root 9 is 3. So minus 10 root 3 plus 3 root 3 is going to be minus 7 root 3 and minus 5. Well, 6 times 3 is 18. Okay, and I'm going to put the minus 5 next to it because we're going to collect those like terms. Minus 7 root 3. And then it's totally simplified to t minus 5 is 13 minus 7 root 3. Okay, so that's doing some adding, subtracting, and doing the multiplying together. So that's it for radicals. You could multiply more than two binomials, you could multiply 3 binomials together, and so on, using the same sort of rules.